Today we will be conducting the experiment where we determine the wear coefficient of the given sample. The given sample is brass. This experiment is conducted using the wear test equipment. Here we have a circular disc which is coupled with an electric motor. And over here we have a position where we can keep the sample, and this is the position where we can place the weights. Now we measure the weight of the given sample. As we can observe, the weight of the given sample is 4.31 grams. Now after we have measured the weight of the sample, we will place the sample in this position of the equipment. After we have fixed the specimen, we place 1 kg in this position of the equipment. Now after that's done, we measure the distance L1, which is from this point to this point, and we measure the distance L2, which is from this point to this point. Now after all the distances are measured and we have placed the weight and the given sample, we switch on the motor and start the stopwatch simultaneously, and we keep the experiment running for 10 minutes. As 10 minutes is now completed, we switch off the motor. And simultaneously we switch off the stopwatch. Now we take the specimen out of the position and we measure the specimen. After we measure the weight of the specimen, we get the final weight of the sample. Now using the formula, K is equal to F into H divided by F into S, where K is the wear coefficient and V is the volume, H is the Brinell hardness number, F is the component force, and S is the rubbing distance. We calculate the wear coefficient. Over here, the volume of the material is going to be mass by density, that's W1 minus W2 by rho, where W1 is the initial weight that was measured and W2 was the final weight that we measured after the experiment was concluded. And F is the component force, where W1 into L2 divided by L1, where L2 and L1 was measured previously. And S is the rubbing distance, which is given by 2 pi N RT, where N is the RPM of the motor, that is 400 RPM, and R is the radius of the disc, that is 90 mm, and T is the duration of revolution, where in this experiment we have done it for 10 minutes. After calculating the component force and the rubbing distance, we can find the wear coefficient of the given sample. Thank you.